Assalamualaikum warahmatullahi wabarakatuh. My name is Irina Batrisha binti Muhammad Zamri, matrix number CF190143. So today I will be talking about our Civil Engineering Mathematics 4 group project. The topic that we chose is application of numerical differentiation. For this project, we are going to talk about 6 things. The first is introduction, second, filler table, third, literature review, fourth, methodology, fifth, result, and lastly, discussion and conclusion.
My name is Haryanti binti Mohsin and I will continue with the introduction for our topic, application of numerical differentiation in UTHM road safety during peak hour. In numerical analysis, numerical differentiation describes algorithm for estimating the derivative of a mathematical function or function subroutine using value of the function and perhaps other knowledge about the function. Numerical analysis is a branch of mathematics and computer science that develops and analyze and implement technique for numerically solving continuous mathematics problem. Such issues arise from real-world application of algebra, geometry, and calculus, and they involve variables that change on a regular basis, as this problem occur in the natural science, social science, engineering, medicine, and business. As for background of study, numerical differentiation is a concept from a discipline of civil engineering that we have related to our study topic. As a result, we picked the traffic volume research to evaluate the number of cars passing a piece of road per unit time at any given time. The unit for traffic count is generally taken as vehicle per day or hour. The unit of measurement for traffic counts is typically car per day or hour. As for problem statement, the issue statement for this study is to conduct research on traffic engineering, with the problem mentioned being the number of cars that utilize their indication when passing through the roundabout in F2 region. Not only that, but we have also see how many various sort of automobile utilize the indicator when approaching the roundabout. Finally, during peak hour in UTHM, the number of cars utilizing the indicator at the roundabout indicates the safety of the road. As for objective of this study is to study to determine the objective from the above mentioned issue statement. That is, 1. To measure the number of vehicles using the left or right signal at the F2 roundabout. Secondly, to observe various vehicles using their signal at the roundabout. And lastly, to determine the road safety at peak hour in UTHM by the number of vehicles using indicator when turning left or right at F2 roundabout. Moving on to the content number 2, filler table.
Moving on to the fourth one, methodology. For this project, a study was conducted to solve the problem of ensuring road safety during peak hours in University Tun Hussein on Malaysia. It was done by observing the amount of vehicles and motorcycles that use signals at a road junction located in the UTHM campus. The data collected was obtained from a statistical research from the traffic engineering subject. The research was conducted from 8 a.m. until 10 a.m. at a road during peak hours. Based on what has been learned in Civil Engineering Mathematics 4, The number of vehicles percentage using signals can be calculated using numerical differentiation. By calculating the data using these formulas as shown, the percentage during the observed hours can be obtained. The equations that will be used are listed as in the slide.
Let's take a look for the fifth component, result. Problem calculation. Table 1 shows the data of cars and motorcycles obtained for the interval of 15 minutes. There are a total of 120 minutes used for this calculation. Now let's take a look for the calculation of data for cars. Use h equal to 15 and t equal to 60 minutes. We do example for two formulas. 2-point forward formula FDF is f prime x equal to f in bracket x plus h close bracket minus fx over h. Now we can substitute all the x and h values. The result for 2-point forward difference formula FDF is 40%. The next one is 2-point backward difference formula. BDF is f prime x equal to fx minus f in bracket x minus h close bracket over h. And we can insert the values of x and h. The result for this formula is 180%. Next one, moving to the 3-point central difference formula, CDF. The result is 70%. Next, 3-point forward difference formula, FDF. The result is 43%. Moving to the next one, 3-point backward difference formula, BDF. The result is 310%. And the last one, 5-point central difference formula, CDF, 91%. Now we are doing for the calculation of data for motorcycle. Again, we use h equal to 15 and t equal to 60 minutes. For the numerical differentiation, the first one, 2-point forward difference formula, FDF, the result is 33%. 2-point backward difference formula, BDF, the result is 73.3%. 3-point central difference formula, CDF, the result is 20%. 3-point FDF, forward difference formula, the result is 46.7%. 3-point backward difference formula, BDF, the result is 123%. And the last one, 5-point central difference formula, CDF, the result is 26.1.
Moving on to the sixth one, discussion and conclusion. In conclusion, approximate values at 60 minutes should be able to be obtained by calculating using the suitable and right formula contained in the numerical differentiation topic. The formulas that can be used have been listed in the methodology slide. Based on the calculation of the data, the answer obtained from f prime x for 5-point central difference indicates that the number of cars that use signals at road junction are higher than the number of motorcycles. The values obtained from the calculation were 91% for cars and 26.1% for motorcycles. From the study, it can be seen how much the drivers and the riders obey the basic rules of being on the road. Since there are a huge gap Between the two results obtained, it can be said that there are more improvements that can be made in the way how drivers and riders act and behave on the road, especially at road junctions in a campus. This is so that any undesirable accidents can be avoided much earlier since there are a lot of students that walk by foot in the campus area. It is much better to avoid than to cure. That is all from my group and me. Thank you.